Hey guys, and welcome to week 4 of the second through fourth year online course. My name is Thomas Darren. I'm the strength and conditioning coordinator here at the college, and I'm going to be talking to you about the next piece of the puzzle when it comes to your programming. And that piece of the puzzle is the energy systems work or conditioning that many of you guys put in your program, but very few people, including coaches, really and truly understand. So what I'm going to do is give you guys 4 quick lessons. The first 2 will be a little bit more on some of the science and some of the fundamental background on what energy systems are. And the next 2 lessons after that will be a little bit more of a practical framework for how you can build your workouts in order to accomplish some of the energy systems goals you may have for your specific training goal that Stefan and Joel had you guys plan out in weeks 1 and 2. So what we're going to do is first we're going to talk about some of the common myths that we see when it comes to energy systems work or conditioning that a lot of people hold, but we're going to try to dispel them throughout these next 4 presentations. The first myth is that interval training, or what's really popular now, HIIT training, is all that someone needs in order to develop their energy system. And that is just simply not true. And it takes a very short-sighted look at what energy systems are and doesn't really give a complete understanding of how multifaceted our energy systems are and how we actually use and produce energy within the body. The next myth that we kind of want to dispel is if a sport is explosive, therefore it's anaerobic, and aerobic work is unnecessary. One of the main problems with this statement is that most people might view their sport as anaerobic, maybe because it's start-stop, let's say rugby or soccer. But in reality, when you actually were to test what energy systems are being used, most anaerobic sports are actually also highly aerobic, and most people don't really understand that about their sport and how to accommodate that within their training cycle. The next myth is if you train slow, you will be slow, and that's obviously not the case. There's room for both slow training and explosive interval training within a program, and it's all part of building a complete energy system approach to your training and to how you guys get ready for anything you're going to desire performance in. And the last myth is the harder you train, the better shape you will be in, which to many of you would mean a direct return on intensity. And while I definitely don't want to go out and say that we don't need to train hard or harder, there simply is not a linear relationship to how hard you train and the improvements that you get out of it, particularly with energy systems work. Because as you'll see in the next few slides, an understanding of the intensities and the timings necessary for specific energy systems is going to be really important, and some of those might mean training a little bit lighter, and some of the other ones might mean training a little bit harder. If you guys have any questions or if you guys don't understand anything that I'm going to be talking about, please feel free to leave a comment in the Q&A of your class, and I can always go back and look through those with the other PE teachers, and we can clarify any misunderstandings that we have. All right, the next piece we're going to talk about is the basics. So what do we actually need to understand in order to even begin having a conversation about energy systems? The first thing we need to understand is that everything comes down to energy and how much energy we can produce, because every single cell in our body and every single function that we need to stay alive requires energy. So what this means is that when we're talking about energy systems, we're not just talking about performance, we're also talking about how we fundamentally stay alive as human beings. So the energy systems allow us to produce energy. They also expend energy along with every other system in the body, and we need to start the discussion there. Conditioning is what I just said. It's directly related to both energy production and energy expenditure. And this relationship between energy production and energy expenditure is what many of you from basic biology in high school would know as homeostasis. So within our body, there's always shifting priorities and different demands being placed on it based on what we are doing, and that would be referred to as homeostasis. So in the next slide, I actually have a little figure that might help with this explanation. So you can see every single system and every single function within the human body has a tolerance limit that's both slightly above what we normally operate at and slightly below. And our body is always trying to stay within those two limits for every system, for every output that it's creating on a daily basis. And that could be blood pH, that could be blood pressure, that could be hydration. If we spend too much time outside of those tolerance limits, that means the body stops producing energy and the cells die. So everything that we do as human beings relies on keeping a very fixed regulation point between all the systems within the body. And the important thing to understand here is that what we view as fatigue is oftentimes spending too much time outside of these tolerance limits. So fatigue is actually it's a protective mechanism within your body that allows your body to shut down systems or shut down your performance before you allow any of these functions or systems to spend too long outside of their comfortable range so that the cells don't die. So on the next slide, what we're going to talk about is how we transfer energy. And this is where we start talking about the two main energy systems that we're going to break apart a little bit further throughout the next slide. So the first energy system that you guys might be familiar with is the aerobic system. The second energy system that you guys might be familiar with is the anaerobic system. And the job of both of these systems is to produce energy. And the molecule that we would define as the fuel that is required for most human function is ATP, or adenosine triphosphate, because that is the currency with which our body essentially runs all muscular work and all cellular functions. So whenever we're talking about any energy system, we are talking about how can we train our body to most efficiently produce ATP in order for us to get the highest level of performance we possibly can without going outside of the normal ranges and throwing our body out of homeostasis, which would then result in our body shutting us down, inducing a large amount of fatigue, and really decreasing our performance. So that's really, if you can understand that fundamental concept, we're well on our way to understanding why we train the energy systems. So the next concept I want to introduce you guys to is the force fatigue curve. And all this curve shows is that there's always a trade-off between the max rate of energy production and the max duration of energy production. And this is going to be how we separate the need for more anaerobic training or the need for more aerobic training. So we can place most activities, most sports on this curve, and you can see weightlifting, shot put, jumps, and discus would not require a large duration of energy production. These are all very explosive sports, so they require a high rate of production and not a high duration. On the opposite end of the spectrum, we have endurance sports, triathlon, marathon, ultramarathon, Ironman, any of those sports. They don't require a high rate of energy production, but they require hours and hours of energy production, which means we have to train our ability to produce energy over an extended period of time. Of note, one of the most interesting ones for you is where I would place the typical tactical environment or the typical tactical athlete, and we talk about this in my fourth year class, would be somewhere between endurance sports and combat sports. So many people view, let's say, infantry tasks as being very powerful or explosive, but the reality is, if you think back to any of the courses you may have been on, muscular endurance and just aerobic endurance tend to be one of the biggest deciding factors in terms of physical performance when it comes to the tactical environment. So when you guys are picking your training programs, if your desire is to improve occupation-specific performance, take note of where the typical tactical environment and where typical courses fall on this relationship between max rate of energy production and max duration of energy production. And more often than not, most military personnel do not spend enough time working on the duration portion because it's simply not as fun as the weightlifting portion. So in summary, to end this presentation, when we talk about energy systems, we're talking about survival and how our body actually functions as much as we are talking about performance and how to improve in the gym, on the field, in the court, or the ice. Both aerobic and anaerobic pathways are used to produce energy, depending on how much energy is needed and the rate and duration that this energy is required in order to perform the task that we are asking of our bodies. But unfortunately, as the previous chart showed, we can't have it all. So there is always a trade-off between duration and rate. And we have to understand that relationship with the goal we are trying to achieve in order to really understand how to guide our own personal training and the types of workouts we need in order to succeed. So that's the end of the first presentation, guys. Take a look back through the diagrams or ask any questions you may have. The next presentation, we're going to talk about the differences between aerobic and the anaerobic energy systems and how they fall within our thought process when we're designing a training program. So I'll see you guys in lesson number 2.